So we are doing problem number 3, part A. 3 forces act simultaneously on an object as shown here. So if you have your object right there, calculate the resultant magnitude and force. So the first thing you want to do is make a diagram like this one where you have and label it north, east, south, west. So north and west are going to be positive, so 67 newtons plus, and then whatever is going to be east is going to be minus, and then north we have 22 newtons, so plus. Now I'm going to do like what we did with the map assignment. I'm going to break this 45, since it's the hypotenuse right here, down into x and y components. So to solve for y, we're going to take the opposite over hypotenuse, which is going to be the 45 times sine of 30, which is going to give you 22.5 newtons. That is going to be north, so therefore it's going to be positive. Then we have 45 times the cosine of 30, since you have x, which is adjacent over hypotenuse, and that's going to give you 38.9711 newtons. But that's going to be east, which is going to be negative. So over here, we're going to minus 38.97, and we're going to add 22.5 newtons, because this is north and north, and this is east versus west. So that is going to give you roughly 28.028 and newtons and 44.5 newtons. And so that's going to be used for your resultant. So that's breaking these into one thing right here, where so the north right here is going to be 44.5 newtons north, and west is going to be the 28.028. Obviously it's not Jordan to scale, so then we're going to use a squared plus b squared equals c squared. And so 44.5 squared plus 28.02 is squared equals to c squared. That's going to give you 2,765.869 ... So that equals c squared. Take the square root of both sides. That's going to give you 52.59 newtons, which is correct. If you're doing sig figs, you should only have 2 sig figs because of here. All these numbers have 2 sig figs. So it's going to be 53 newtons. That's your resultant magnitude. Now to find the angle, the angle is part B, which will be done by Jeremy.